Hello guys. Introduce my name is Farilio Lala. And now I will explain about logic. Let's start with basic logic. Logic is the study of reasoning and thinking correctly. It helps us determine whether a statement is true or false. In logic, we use statements called propositions, which are sentences that can be either true, T, or false, F, but not both. For example, the sky is blue, true. 2 plus 2 is equal to 5, false. We can combine these propositions using logical operators. And means both statements must be true. Or means at least one statement is true. Not reverses the truth value. For example, if A equals true and B equals false, A and B equals false. A or B equals true. Not A equals false. This is called Boolean logic, named after George Boole, who developed the system used in mathematics and computing. Now, let's move to computer logic. Computers use logic to make decisions and process data. Every operation in a computer, such as calculations, comparisons, and program control, is based on binary logic, which uses only two values, 1, true, and 0, false. In hardware, these values are represented by electric signals. Voltage present equals 1. No voltage equals 0. Logic gates are the building blocks of computer logic. They perform basic logical operations using electrical circuits. And gate outputs 1 only if both inputs are 1. Or gate outputs 1 if at least one input is 1. Not gate outputs the opposite value. By combining logic gates, computers can perform complex tasks such as addition, data comparison, and running software programs. So in summary, basic logic helps us reason and understand truth values. Computer logic applies those same logical principles using binary, ones and zeros, inside digital circuits. And that's how logic connects human reasoning with computer processing. It's the foundation of all computing. In basic logic, we also use something called truth tables. A truth table shows all possible combinations of truth values for given statements and the result of a logical operation. For example, here's the truth table for the AND operator. This helps us analyze logic expressions clearly and see how the output depends on the inputs. Logic is not only used in computers, it's also important in mathematics, philosophy, and everyday decision-making. For example, when we say, if it rains, then I'll stay home, that's a conditional statement, a basic logic form known as implication. Now, back to computer logic. Computers apply these logical concepts in digital circuits. Inside your computer, millions of transistors work as electronic switches that turn on, 1, or OFF, 0. These switches are arranged in logic gates, and gates are combined to form circuits that can add numbers, using adder circuits, compare data, using comparators, and store information, using memory units. When we write computer programs, logic also plays a huge role. For example, in programming we often use if-else statements. Here, the computer uses logical comparison to decide what action to perform, just like human reasoning but in binary form.